So hello YouTube, this is a video on dynamic or non-linear simulation in Solidworks. So let's begin. Take a new part. Now here take front plane sketch, take a circle. Okay, change the units to mmgs, millimeter. Then give the dimension. Okay, so the dimension give 100. Enter. Then take a 3-point arc. Take somewhere point here, here, and draw arc. Okay, select the arc. Select the circle. Make tangent. Now draw a line from the center, select the line, make it for construction, give the dimension, suppose 200. Okay, wait, let me see. Okay, then draw a line. Now again select this line, select this arc, select the line, select the arc, make tangent, then select this point, this line, and make a distance of 10 mm. Okay, select both of the lines, go to mirror entities. Okay, control Z, go to mirror entities. Now select both the lines separately, select the center line as the mirror line, click on OK. Okay, now again take a 3-point arc, take this point, take this point, and this is the line. Okay, take the circle and arc and make them tangent. Give the dimension, suppose 60. Now again draw a line of small length, select the arc, select the line, select the arc line and make them tangent. Now again select both of them and make a distance of suppose 13 only. Okay, sorry, double click 13. Okay, now again go to mirror entities, choose this line, go to and mirror it about center line. Now go to trim entities, trim the middle portion. Okay, now go to the offset entities, select the upper lines and make it reverse an offset of 5 and cap the ends with arc. Okay, select OK. Then again go to offset entities, select the bottom arc, again 5 mm and cap the ends, click on OK. So see, this we have made. Now go to features, go to extrude. Here select mid plane, keep the distance 50 or suppose 30. Okay, see, now just take this portion, select sketch. Okay, exit, take this portion, select sketch, convert entity, go to features, extrude and keep the condition up to next, click on OK. So see, this portion is made. So this is our geometry that we are making. Okay, now just go to control S. Okay, then save here with number 1, save. Okay, now go to again you choose assembly, click on OK. Now here insert the component. So this is our component. Now we will make a part inside the assembly itself. So go to assembly, here below insert component, select new part. Okay, then select this plane and click on sketch. Now for normal direction press Ctrl 8. Now select a circle from center and drag up till this point, click on OK. Okay, now go to features, go to extrude boss base, select in the reverse direction and okay, we have not changed the dimensions na. Okay, just go to mmjs. Now go to extrude boss base, select the circle, change the direction and distance keep 30, click on OK. Okay, then you can also go to fillet, select this edge, select this edge, click on OK. So see, this we have made. Now just click on exit. Okay, so this is the part that we have made. Now go to SolidWorks add-ins, click on SolidWorks simulation. The simulation tab will appear. Click on the simulation tab. Here go to new study. Okay. And here choose nonlinear. So we are choosing nonlinear analysis. Click on OK. Go to parts. So this is our part 1. I am going to provide a copper material to this, and this is our part 2. Here I'm going to provide a rubber material. Okay. So this is the material. Switch off the real view graphics. Okay. So see, now in the connections, I'm going to right click and choose local interaction. Now we need to provide connection between this circular element and these faces. So we'll select this face, right click on the face and go to select tangency. Okay. So the tangent face is selected. Same, select this face, right click and again select tangency. Okay. So see, the entire tangent faces are selected properly. Okay. Now go to this second face. Here select this face, this face, this face, and now click on OK. Okay, you can also make it again go to edit definition. Here also include coefficient of friction, and now click OK. Okay, now go to fixtures. Here go to fixed geometry. The fixed geometry, choose this face. You can also choose this face if you want, and here click on OK. Okay, so this is a fixed geometry. Now again go to fixture, go to fixed geometry. This time choose this surface, this surface, this surface. Now go to advanced. Here select the reference plane as a right plane. Okay, and now choose the direction, this direction. So you see the direction is going in reverse. So I will just go down, symbol setting, increase the symbol size. Okay, so the symbol is going in this direction. So just click on reverse direction, and here give the dimension of 20 mm, 20 mm. Okay, and here left and right keep 0. Now click on OK. Okay, the symbol is too much big. Symbol has become. Let it be. Go to mesh, go to create mesh, and create a mesh accordingly. So see, the body is meshed. Now you need to just run the study. So click on run. So the study is running. See. Okay. So the result is completed. Now what we'll do is we'll again go to reference geometry. Here click on edit definition, and yes, here in the symbol setting, reduce the size of the symbol. Okay. Now what we did, we took 20 mm. So it came up till here. We'll just increase this direction. We'll keep it to 40. Okay. And let's see now what the result. So what we are doing is, see, this direction is negative x direction. So in the negative x direction, we are given the command that it will move, this body will move in a negative x direction 40 mm. Okay. Now because this body is in contact with these two faces, or this body, we are given a contact relationship also, local interaction relationship. Then this body, because it is in contact with this body, it will insert stresses onto this body. Okay. It will force this body to open. So that is what we are going to simulate. Okay. So we are given the direction, we are given the the distance that it is going to move in the negative x direction, and here in the y direction and z direction we have chosen 0 Okay, so click OK and rerun the study. So hopefully, okay. So see, this is our final result. Okay, that we have made. And see, you can see the stresses here. They have given that the plot steps are 14 steps. So before the circle was at this position, so from this position till this position, the distance that we provided, it has divided that distance into 14 steps, and at every step different amount of stress was generated, right? So nonlinear analysis is the analysis where different amount of stresses is generated, or the stresses varies with respect to time. So these plot steps indicate the time that it took from here to here. okay, for this ball to move. And that, and at every step, what were the stresses generated, that we can visualize through this graph. So you can right click on the graph, go to chart option, and here choose it to floating number and reduce the decimal to 0. Click on OK. So see, at this position, the stresses at this point is maximum, and the maximum stresses is 558. Okay, so you should just count the digit 1, 2, 3, 4, 5, 6, 7, 8, 9 digits starting with a 5. We provided copper material, so you can go on to details. And here, if you see what was the yield strength, the yield strength is also a 9-digit number, but it is starting with 2.5. So this is half a times more stress is generated. So this body is so this simulation is not safe, and too much stresses will be generated on the copper at this point. So the factor of safety will be less than 1. It might be 0.5. Okay, so let's see how to see factor of safety. Just right click on result, go to define factor of safety, here click on OK. So see, the factor of safety I said it could be 0.5. So the factor of safety is found to be 0.46. Okay, so so copper is not a safe material for this kind of assembly. We should change the material, is what the simulation is suggesting to us. Okay, now if you want to see displacement, see the maximum displacement is of course going to be this ball like structure, because it moved from this point till this point. And we are interested in the displacement of this point. Okay, because this point was closed before. If you go to the model, you can see. So because this was the distance, now because the ball moved in the left direction, it opened up. So how much it opened up? So if you want to see that, what we'll just go on displacement, and here again go to chart option, go to floating number, click on OK. So see, the displacement they are saying it is of 40 mm. Okay, at this point also, and this point also. So okay, that is enough. Now what we'll do is we'll just animate our result. We'll go to stresses. Or we'll go to displacement only. Okay, we'll animate both of them. So just right click, click on animation. Now in the static animation, you can change the frame rate, but in the dynamic animation, you cannot change the frame rate. Okay, because there are 14 plot steps. The animation, the frames it is showing is 14 frames only. So if you want to increase the frames, you will have to increase the plot steps. Okay. So for now, we'll keep it 14 only. So see, this is the animation. You can also decrease the speed if you want. And you can also save this animation as a AVI file. Okay. So just now close it. So this is about the nonlinear simulation. I have already made another video where I explained the nonlinear simulation on a sheet metal bending assembly. So you can also watch that video. Thanks a lot for watching the entire video, whoever watched till end, and stay tuned for the upcoming videos. Thanks a lot.